We have it in place. And then, so good afternoon, everyone, and welcome to today's CKUA STEM Pro session dedicated to open innovation science. We're a field that sits at the intersection of research, collaboration, and real world impact. So today we are honored to host two leading scholars whose work has significantly shaped how we understand and practice innovation in science. So first, I'll ask the presentation to give her speech to Dr. Susanne Beck, who's assistant professor at the ISM-Analytics. No, I think we'll actually kick off with you, right, Susanne? So, yes, and who's assistant professor at ISM-Analytics group. So please. The floor is yours.
Thank you very much. Actually, we're doing a collaboration ourselves today with Marion, so we have integrated our slides, so we will have a very fluid interaction here. So let me share the slides first. Here you go. Can you confirm that you see the full screen? Wonderful.
Thank you.
Thank you. So welcome from our side. It's really a pleasure to be here with you today and to talk about open innovation in science, which is a topic that has been following Marion and I for I think for 10 years almost now. So it's really a pleasure to share what we've been doing. But before we get into the details, we wanted to introduce ourselves a little bit so that you just know, who the faces are that are talking to you. And I'll just gonna start before I hand it over to Marion. So as Susanne had already mentioned, I'm assistant prof at Warwick Business School, and my main research focus is on the organization of scientific knowledge production. So basically, I want to understand how we collaborate in order to produce scientific knowledge. Or if my grandma asks me, I tell her that I do experiments on scientists in order to understand how they collaborate. So that's actually, I think the coolest part of my job. Before I was at Warwick, I was at Copenhagen Business School, and I was at the Open Innovation and Science Center, which is a research center that actually Marion founded. So this is why I think it's brilliant that she's here today, because she has all the background information. But and we did lots of things on open innovation in science. And in fact, we actually founded an association just 2 years ago, focusing on the advancement of science and innovation, which is our current vehicle, how we carry out some of our open innovation and science activities. But before I became an academic, I was also working in industry. I was working for automotive companies. I was working for Volkswagen and Porsche in the strategy departments, market research, innovation departments, and I was an independent consultant in several sectors, but not only in Europe, but also in South America. So for almost 10 years, I was living in Argentina and Chile. And one of the things I did there is probably also what kind of reflects how I approach problems today, because for almost 2 years, I was a semi-professional rally driver where I, really tried to find paths where no paths are. And this is how I see research as well. So I get excited, then no one else can see where the street continues, basically. So this is probably one of the images that people take away from my talks. But now let me hand it over to Marion, who has actually exciting CV.
I can never compete with you, Susanne, when it comes to the exciting stuff. So thank you so much for inviting me to be here today. It's a real pleasure and honor to working with you. And I hope that we are able to get to know each other a lot better in the months or years to come. I'm Professor of Innovation Management at Copenhagen Business School at the Department of Strategy Innovation. And let me make this short. So in my research, I also try to better understand how to strategize and organize open and collaborative knowledge production, both in scientific research, but also in corporate innovation. I teach strategy, management, organizations of science and innovation in various programs at Copenhagen Business School, but also in international executive education programs. And I have founded and run multiple science or innovation labs all across the globe. I also do a lot of impact work, trying to use the research we do to help organizations, corporate companies, but also scientific organizations, public sector organizations, help them to use open and collaborative strategies for improving the productivity and impact of their initiatives, particularly with respect to grand challenges involving sustainability or health issues. Yeah, so I think that's long enough. Thank you very much. And Susanne, let's get started.
Absolutely. Thank you very much, Marion. So the roadmap for today consists of 3 main blocks. And the first one is to kind of share with you a conceptual understanding what we mean with open innovation in science before we go into a couple of examples where we show collaborations with distant actors, with distant knowledge actors, how this can play out and what are the contingencies that are relevant. And the third part is an open discussion where we really want to interact with you, learn more about the types of collaborations that you have, where you think, or challenges where you think that collaborations can be a means to tackle them, etc. So we really start from this conceptual understanding, also to give you some tools and some vocabulary where you can think of when to apply these sorts of ideas to your own research, because Bo and Juliana were so nice to share your CVs or your list of what your backgrounds are, and it's so a diverse group, and we are so excited to learn how you carry out your research. So we really hope to kind of get this discussion started today. So let us start with the conceptual foundations, and you may wonder, why do we actually think about openness and collaboration in science? And one reason is coming from this understanding of how we can organize scientific knowledge production processes. We learned, or we observed, that over the last decades we see a decline in scientific productivity, and at the same time we're seeing lots of societal challenges. Lots of different ones, starting from sustainability issues, but also to unstable situations all around the globe. And when we think like this decline in scientific productivity means that we need to invest more resources, more money, more time, more efforts in kind of reaching the knowledge frontier to really find novel ideas to make scientific breakthroughs. And at the same time, the publications that we see that they are increasing. The rate of publication increases. There are more and more publications, but the actual contributions of these many publications is rather incremental. So we see a tendency towards more and more incrementalism. And one remedy that has been proposed for exactly this incrementalism and this decline in scientific productivity are cross-boundary collaborations. When I say cross-boundary collaborations, what I mean is not, what is the boundary I'm talking about, right? It's a knowledge boundary. So when we think about cross-boundary collaborations, we're thinking about bringing together knowledge actors that have a very different mindset, that have a very different understanding, that have different training. So that could be different disciplines, right? As a medical researcher, you have a very different training and knowledge and mindset than a sociologist. And there is the knowledge recombination theory that tells us the more distant the actors are that you bring together to solve a problem, the more novel and the more creative the outcome can be. So understanding knowledge distance as a concept that can provide us with a very rich source for finding novel solutions. The paradox is, however, while it can be very beneficial to bring these distant actors together, it's also extremely risky, because collaborations that bring together these diverse actors are very likely or very prone to failure, because there's a different understanding. There might be different motives. There might be different goals. It's very hard to communicate with each other because we're using different terminologies and different language. And especially for early career researchers, they might think twice before they engage in such a collaboration, because they need to publish. We have this publish or perish culture, and if you want to keep your job, you need to produce publications. So for them, it's an extra hurdle to collaborate.
Я сижу дальше в Zoom.
By the way, if you have any questions, please shoot anytime, okay? So we can really start this discussion now, even though then we have a discussion later on. But if anything is unclear and you want to clarify the right way, please ask us. Right. So because of the power of collaborations, it has been discussed in many different fields. So openness and collaboration is not new. It has been discussed in academic literature for decades. But people talk very differently about it. Medical researchers have been talking about patient engagement for decades. The same in sociology. Innovation scholars have the concept have thought about crowdsourcing as one means to collect knowledge from distant sources. So openness and collaboration has been discussed quite a lot, but it was always in silos. This discussions was always dispersed. And we thought, okay, how can we bring this together? Because if we have a joint understanding of what openness and collaboration can mean in science, we can actually produce and pull out a joint research agenda and think about how to move forward when it comes to understanding openness and collaboration in science. And we thought we don't want to just talk about it. We actually want to produce something tangible. And when I say we, I mean this lovely group of people. And this picture, I love this picture because it is stereotypical for interdisciplinary collaborations. So if you look here on the left side, for instance, so you see this young lady. I don't know if you see my mouse, but on the left side, you see this young lady. She's a psychologist. So she's basically observing the group, right? which I think is very nice stereotypically. Then in the back end, you have the two male scholars who are physicists, who are feeling probably a bit awkward in this big crowd of people, right? And in the front, you have innovation scholars that are really like, outgoing and shiny and want to contribute or want to be on the forefront in terms of being part of the group. So I think it's a nice picture just because it shows the very different disciplines. And now this is not more seriously, these are very different disciplines, but we wanted to engage in creating this shared understanding when and under what conditions it does make sense to think about open and collaborative practices. So we wrote together this paper. It's almost 50 authors in total, with all the different disciplines that I just mentioned. We have sociologists, particle physicists, medical researchers, ethnographers, etc., etc. And altogether, we conceptualized open innovation in science as a foundational framework to advancing the understanding of the antecedents, contingencies, and consequences of open and collaborative research practices. And with open and collaborative research practices, we are referring to all sorts of different types, for instance, academia-industry collaborations, or crowd science, or when you want to share materials or data, for instance. And these practices can be applied along the entire research process, so from the ideation to actually carrying out the research to disseminating the research. And one important aspect here is that we emphasize that we never consider collaboration as an end in itself. It's always just a means to produce more novel and impactful research. So if there is a challenge, collaboration can be a means to achieve a better solution, but just collaborating for the sake of collaboration is something that we need to consider very carefully. So collaboration is not an end in itself. Here's a formal definition, but I rather would like to walk you through the model which is presented here. And it basically consists of 3 parts, and I want to walk you through these 3 parts step by step because it's a big conceptual model. And let me start in the middle part here, where you see the open innovation and science practices, and there are inbound and outbound practices. And this refers to the knowledge flows from either outside academia to your own research. So when you bring knowledge from outside academia or from a different field to your own research, this would be an inbound practice, like crowdsourcing knowledge from the general public, for instance. While when you share your own scientific knowledge with external actors, that would be an outbound OIS practice, right? And as the model shows, this goes along the entire research process, from conceptualization to carrying out research to documenting it. And this can, of course, this is a stylized, it's an ideal typical process, and of course there are loops, but just in a simplified way, along the entire research process, it's possible to collaborate with other actors. And in these practices, we have two sets of collaborations. One set of collaborative practices refers to practices where you engage scientists only, academic scientists. So this is basically yourself and a scientist from another field, very distant field. That could be an interdisciplinary collaboration, but it can also be when you want to share the same infrastructure, the famous example of CERN, for instance, but also if you want to share material or data, or if you want to publish, like open science practices, like open publishing are also included there. The second set of collaborative and open practices are collaborations where you have scientists and non-academic actors, such as the general public or experts by experience, such as patients who really live in a given experience that the scientists often lack. It can also industry partners or policymakers and governments. So this is kind of what we try to summarize. All these different practices are the heart of the model. But then again, we say it's important to consider the antecedents and the boundary conditions, to think about when does it make sense to collaborate, and what affects to what extent a collaboration can be successful. And we grouped these antecedents along different levels. So for instance, on the individual level, if your own background, your own training, whether you had collaboration training as a PhD, but also if the problems you're working on in your research, all these sorts of things influence whether an individual is capable and willing to collaborate. And there might be many attitudes and identities. The self-identity that I have as for myself as a researcher is relevant how I engage in collaborations. But also, when you think about the organizations we're working for, the organizational setup heavily influences to what extent individuals, scientists are able and willing to engage in a collaboration. If there are organizational incentives for us to engage with other actors, then we're probably it's easier for us to do so, and vice versa. But there are also obviously disciplinary differences or new technologies. Generative AI is going to change how we collaborate all together, right? A new chance, new opportunities, and new difficulties. And the societal level is kind of sharing this embedded context, how policy is supporting what type of research is supported to be carried out. So these are how these practices are influenced. And finally, the third block is the outcomes. And the model emphasizes that the outcomes are not only at the end of a research process. So it's not only about what the results of our projects are, but it's much more all the outputs that we create along the research process. This can be proposals that we write, or data sets that we develop, or protocols that we have, code that we develop, teaching materials, all sorts of things that emerge from the research throughout the entire process can have scientific and societal impact, which then again feeds into the entire model. So this is kind of the conceptual foundation. I know it's quite a lot, but there is the general idea of having this research process and how different factors influenced when it makes sense, and that along the entire research process there can be relevant outputs that can have impact in its own right. This is kind of the general idea that brings together these different previously dispersed silos talking about openness and collaboration in science. But now let's make it more concrete and walk through the different examples that we have. And to do so, let me just go back a little bit in time, because when we think about where do scientific breakthroughs come from, where do scientific innovations come from, we tend to have specific people in mind, right? This is just a selection of people. If we go just a couple of decades back, we have Tim Berners-Lee, who came up with the World Wide Web, or Hedy Lamarr, who is actually an actor, but in her free time ran scientific experiments next to the set where we were filming a movie. And she came up with the frequency hopping spread spectrum technology. So there are specific individuals that are famous for the breakthroughs that they accomplished. Now, when we fast forward to today, let me show you this person here. This is Gernot Grömer, and probably no one has ever heard of Gernot Grömer, right? He's an astronaut at the Austrian Science Agency, and he is one of 300 people who developed Ingenuity. And you might have heard Ingenuity because Ingenuity is the helicopter which is attached to the NASA Perseverance Mars rover. Ingenuity, in fact, is the first ever powered flight who started from a different planet than Earth, which is super crazy. Like, this is really cool. And Gernot Grömer was one person out of many to contribute to that. So the larger point being that today, in order to achieve a scientific breakthroughs, we need these larger teams, larger collaborations, because all these different knowledge bits and pieces come together. If you think about the NASA Perseverance rover, there are almost 5,000 people involved, coming from all sorts of organizations. From NASA, which is very, very famous, obviously, but also many academic institutions, small and big ones. There are partly also academic teams of 1 and 2 people involved. We also have AI and tech companies, not to speak of all the different international private sector collaborations that all led to the many experiments that are located on the Perseverance rover. So here you see how all different actors came together to kind of pull this off. And just to link this back to what we said in the beginning, that this knowledge recombination is relevant or can be a useful means in order to push the knowledge frontier. And in order for this knowledge to come together, these actors that you bring into your research don't necessarily need the capability to do research by themselves. But maybe they have relevant knowledge, they have relevant ideas or problems or data that they can contribute to your research. So these collaboration actors are not necessarily, they don't need scientific training, but they can bring other elements to your research that can be extremely beneficial. And these actors that are not academic scientists or that go beyond that is what we wanted to bring you some examples. And Marion is going to show you many different examples from several sectors in a minute. But this is just, how we link it to the model, right? So these are the different actors you could collaborate with. And there are many of these, but we wanted to focus on three different distant actors which you could collaborate with. And one, and this is where you probably have most experience with as well, is interdisciplinary collaboration. And as we briefly mentioned, generative AI is changing how we collaborate. And we did a couple of years ago an experiment, and actually it was May 2022. So this was half a year before GenAI or ChatGPT was made public, or was made available to the public. And we ran an experiment at the annual conference that we're organizing. And here's what we did. We brought together very interdisciplinary scholars from sociology and psychology and particle physics and medical researchers And we asked them to sit together and think about a novel research idea for a grant application. So super difficult because they all have different mindsets and different knowledge, and this was very challenging. And in the first round, we asked them to do this, just sit on a table and work together as you would when you usually collaborate. And then in a second round, we asked them to use an AI tool. And back then, this was Iris AI. Iris AI was a front runner when it came to summarizing scientific knowledge, and see how AI can help you to collaborate. So they now had access to very distant knowledge that they could include in their own proposals. And with access, I not only mean that they could, read the papers, but the AI translated the knowledge relevant to their problem, and they could include this. And at the end, we asked our participants to reflect both on the output of their collaboration and how GenAI influenced the output, but also how it felt for them, how they felt the collaboration was going. And they said it was fantastic to kind of have access to this new and distant knowledge, because this again opened up their knowledge space, but that the integration itself of this knowledge was extremely hard, and that there are more mechanisms needed. So we learned that there's lots of behavioral and cognitive challenges related to integrating AI into our collaborations. And we have summarized this a little bit, and again, we share the slides, so this is something where we are happy to share more information on if this is of interest. Now, moving on to crowds as input for our own research. You may think, well, this is crowdsourcing, you know this, you have seen some crowdsourcing or crowd science challenges, and it always seems to be so applied problems, right? When you think of counting birds and things like that. But I want to share with you one example from NASA. They also engaged the crowd. And NASA, this is a video, again, it's in the slides, it shows, that NASA has a very strong organizational identity. The scientists there are trained to solve the problems by themselves, right? That's why they work there. They want to solve the problems. And NASA then had some funding cuts that forced them to kind of reduce the costs of their own internal problem solving, which is why they engaged in an open innovation experiment, where they formulated several challenges and put them on 3 crowdsourcing platforms. So these are the different divisions, and they came up with 14 different challenges, and they published them on Innocentive, Jet2, and Topcoder. So these are hardcore scientific problems. And within 3 months, more than 3,000 people responded to their challenges. And from the 14 challenges that they put on the different platforms, most of them were either completely solved or partially solved, even though these were like medical consumable tracking, or simply a simple microgravity laundry system, how to, wash your clothing up in space. So these are very, yes, Andre, 1 second. These are hardcore challenges that they then were able to solve. And I'm going to show you one of the stellar solutions in a second. But before that, I'm going to answer Andre's question.
Yeah, I'm interested in IP and solution and commercial part of the solution.
Wonderful.
So how they handle it.
Wonderful, thank you. So Marion is probably going to talk more about IP solutions later on when we talk about novel forms of collaborations with industry. In this case, this was given that they formulated the challenges, so there was no IP involved. So basically, the way they formulated the challenges was open. Right? There were no IP restrictions in how they formulated the challenges. So all the contributions as well were basically open. This was the open approach that they had. And this is quite fascinating, because the outstanding solution here, one of the problems they had was the calculation and prediction of solar flares. So solar flares are extremely dangerous it can disturb GPS, it can lead to blackouts. It's life-threatening for astronauts who are actually in space, leaving their space station, right? And for decades, the NASA scientists, the algorithm that they had was only able to predict solar flares 1 or 2 hours before they were actually happening with 20% accuracy. So extremely low. While up until, so they formulated this as a challenge and said, hey, we need to improve our algorithm. And the goal was to be, to predict it for a longer time and with a higher accuracy. They were maybe thinking maybe they can predict it 4 hours in advance, something like that. But actually, this guy here, this is Bruce Cragen from New Hampshire, the middle of nowhere in the US, and it's a retired radio frequency engineer. So he has no scientific formal training whatsoever. And he, with his background as radio frequency engineer, came up with a solution that made it possible for NASA to predict solar flares 24 hours in advance with 70% accuracy. So this is magnitude better. That made the life for the astronauts much safer, and with predicting solar flares, they can basically spare a lot of money, make GPS workarounds, etc., etc., etc. So all the solutions that they could now develop based on this new algorithm were extremely high. And this was the crowd challenge that NASA developed, right? But there are many different ways how you can engage the crowd, and actually there are so many that Marion decided to write an entire book about it to get to how you can engage crowds in scientific research. And this is kind of the introduction or handing over to Marion to walk you through some more examples.
Thank you, Susanne. Could you just for a moment stop sharing the slides just to see the group a bit better? Thank you so much. So maybe just a quick follow-up answer to Andre, to your question. The examples that Susanne has been showing, the crowdsourcing challenges that NASA has been running, they were implemented using established crowdsourcing platforms such as Incentive or Topcoder. And usually when it comes to intellectual property rights, and that was your question, if I got that right, these platforms have particular intellectual property, contractual arrangements where either they have a winner takes it all model. So the winners of these challenges get a certain amount of money for winning the challenges in exchange for their intellectual property. So that's one model. But what we have been seeing over the past couple of years, there's more and more challenges that are not price-based challenges, but collaboration-based challenges, in a sense that the winner or the winners are invited to negotiate a contractual arrangement with the seeker. So it's not a particular price money. It could be an R&D collaboration contract. It could be a hiring contract. It could be an out-licensing contract. Yeah. So there are different ways of dealing with IP on these platforms. Does that help, Andre?
Yeah. Thank you.
Yeah.
Thank you.
Excellent. All right. Before we start into that, could you just help me a little bit? Because Susanne assumed that you all know crowd science. She said you all know counting birds and so on. But could you help me? Could you just, raise your hand in Zoom or so? Let me know who of you has already run a crowd science project. So Ivan has done that, I see. Who else has been doing a crowd science project? Anyone in here?
I think
No?
I took part in some crowdsourced project because
Okay.
Kaggle platform, it's like
Yeah.
a very similar you describe,
Yeah.
and there are a lot of similar challenge.
Yeah. Okay, excellent. So we have some people who were actually on the crowd side and some who have run projects. Marion, you raised your hand, so you've done a crowd science project. What was it? Can you share it?
Yeah, so it was a long time ago, but still we've got some project with the geoinformational system about the condition of hiking trails in Ukrainian Carpathians. So we basically gathered the feedback and then did some small prognosis on how the hiking trail was
Okay.
the condition of it was degrading through the time.
Mhm. And who was the crowd? Anyone living in Ukraine or anyone living on the globe, or did you target a particular crowd?
We actually targeted like the online communities of hikers in the Carpathian Mountains. So we really at that time had the access to communicate with the people who are actually hiking. So it was pretty niche project, I would say.
Super. Thank you for sharing it, Marion. I also see in the chat that some say that's a new concept in Ukraine, and someone mentioned, and Andrew, you did that as well, the Kaggle platform. And the Kaggle is a crowdsourcing platform mainly for data science challenges. It's mainly used by companies as those who crowdsource problems, not so much scientific research institutions. So maybe while you can, of course, use it also as a scientist, like NASA did it, but maybe let's take this concept and bring it to the world of science now and talk a little bit about how you as scientists could use the power of crowds. And Susanne, since you are should I share the slides, or will you share the slides? What do you prefer?
I can share them, that's fine.
Okay, super, thank you. Then please, could you share the slides again?
Yep.
All right. So as Susanne mentioned, together with Susanne and other co-authors such as Henry Sauermann from ESMT Berlin, we've been doing a lot of research on the role and value of involving crowds of citizens and other societal stakeholders in scientific research. We have also done lots of work with scientists from different fields, working with medical scientists, with life scientists, with physicists. I have been working a lot with neuroscientists to try and develop these crowd science projects and implement them. And at some point, Henry and I decided that we should kind of aggregate all that knowledge and put it up in a book. And the book is available, open access. So if you wanna use the book and all the tools we've developed for running crowd science projects, feel free to scan the QR code or go on our website, sciencewithcrowds.org. All the book, all the materials are freely available to anyone for their use. The book has primarily been written for scientists from different fields to show them how they can improve the productivity and the societal impact of their own research by engaging with crowds of citizens and other societal stakeholders. But it has also been written for citizens who want to participate in crowd science projects, for policymakers who want to evaluate crowd science projects, and for funding organizations who want to find out whether a crowd science project is worth funding. So if we move on to the next slide, Susanne, please. We've seen crowd science projects in a lot of fields. For example, the Suniverse platform is one of the largest crowd science platforms, not so much a crowdsourcing platform like Kaggle. On Suniverse, scientists from different fields run crowd science challenges, mainly with respect to image classification. If you have 1 million brain scans of whatever, a neuroscience study, or tumor scans, or scans of logbooks of old ships when you're a historian, or small video data of whatever, if you're a linguist, you can go on Suniverse, you can ask the Suniverse crowd, and it's millions of people all across the globe, to help you classify these images. And I will come back to some of more concrete examples later. Susanne, next one, please. Another crowd science project that Susanne and I have been running a couple of years ago was in the field of experimental and clinical traumatology. So basically the research on accidental injuries, where a large-scale research group in experimental traumatology wanted to ask their crowd of patients and medical doctors and nurses, what are the relevant research questions that we as scientists should study? And we got more than 800 research questions submitted by the crowd. Or, Susanne, next one, please. Probably something that the medical scientists among you may be familiar with. This is a picture from Foldit. So this is one of the largest crowd science projects where millions of people all around the globe play games, but not for the sake of playing games, but for the sake of disentangling complex protein folding challenges and identifying protein structures in order to fuel research pipelines in Alzheimer's research or HIV research. Or next example, Susanne, please. A very different crowd science project in the field of climate research, where in Belgium, in the city of Antwerp, thousands of citizens of the city of Antwerp collectively engaged in collecting environmental data, such as air quality, air pollution data, traffic data, to do a research project on climate change, and then also to use the data generated in this project to inform policymakers to make respective changes. Or last but not least, a totally different example again from the Natural History Museum in Vienna. This is research in ancient weaving techniques. So that's historical research here, where a small crowd of experts in ancient weaving techniques has gathered at the museum, trying to disentangle complex ancient techniques in order to better understand how these techniques have been working back then. So, Susanne, please go to the next slide. From a couple of examples to some more, to some statistics on a larger scale. Henry and I use data from SciStarter.org, one of the largest platforms that inform you about crowd science projects from all around the globe. We tried to identify in which scientific fields do scientists run crowd science projects. What you can see here is that most projects are environmental research, in climate research, in biology, in zoology, in plant research, but there are also projects in other fields, including the social sciences, quite a lot of projects in astronomy, physics, in computer science, in earth sciences, in medicine, in agriculture and food. Yes, we have a question by Ivan. Feel free to speak up, Ivan.
Yep, thank you. So the main question about the crowd science projects from the perspective of data collection.
Yes.
What about reliability of such data? How to estimate it if it suits?
Yeah, that's a very good question, Ivan, and we discussed this in the book extensively. There's a lot of discussion on, is crowdsourced data, is that valid data? And we've seen, so two different types of answers to this. First of all, of course, when you plan a crowd science project, you have to make sure that all relevant aspects of research integrity are taken care of. So how can you design a project to ensure data quality? So that's a big deal. And we probably don't have time for this in this talk, but I'm happy to, if you email me, I'm happy to point you to the respective chapters in the book. So that's one thing, and it's possible. And the second answer is, we've seen a lot of papers published in the best journals in the world, like Science and Nature, who use crowdsourced data. So if you do it right, if you design a project in the right way, you can get very reliable and valid data in different kinds of fields. But, and there's a big difference in terms of who runs and coordinates these projects versus if it's just citizen-driven projects, not collected for the sake of scientific research, but for example, for the sake of making policymakers aware of environmental issues, for example. So important question, but there are ways in the design of such a project to make sure that there is a reliable data quality. And I'll get back to that in a couple of slides. Is that okay, Ivan?
Yep, thank you.
All right, let's look into the next slide, please. And that is something that Susanne already mentioned in the beginning, which is part of the entire open innovation and science research field, that we're not talking about just later stages of the research process where we engage with external actors in some form when it comes to diffusion and translating research. It's also not only about data collection. While most crowd or citizen science projects are for collecting or processing data, there's a lot of research projects out there that benefit from crowd engagement in other stages of the research process. For example, when it comes to identifying research questions. Also, and probably even extremely important also for you to think about using crowdsourcing as a mechanism for raising funding for scientific research projects. Using crowds or engaging crowds in developing methods and materials. Engaging crowds in solving problems, as we've seen it with the NASA example that Susanne has been giving. Engaging crowds in analyzing data and writing up scientific publications, and then, of course, also in diffusing and translating scientific results. So if we go to the next slide, Susanne, please. One important aspect when we talk about crowds is to think about who is the crowd, and that is also a little bit speaking to Ivan's questions, If you design a crowd science project properly so that you actually contribute to scientific research with all the rigor and relevance issues that we are required to achieve, then you have to think about who is your crowd strategically. You may not engage just anyone. You may more specifically think about, if you're interested in a particular in studying a particular in a particular disease, then patients and medical doctors or healthcare professionals in more general may have relevant knowledge. If you are interested in engaging the crowd for classifying images of whatever brain scans, then anyone with basic cognitive skills may be able to help you. So in the book, we also talk about that individual crowd members can have different characteristics. They may live or operate in different places on Earth. They may be part of different organizations. They may have different knowledge and skills, so general cognitive skills, specialized skills, for example, in ancient weaving techniques or in data science, or they may have experiential knowledge as users of something, such as patients who are affected by a particular kind of disease. They may have a bit of time, they may have a lot of time to help you. They may help you once, they may help you multiple times. They may contribute their knowledge, but they also may contribute financial resources or some kind of other materials, such as their computers, their computing powers, their iPhones, whatever. But then also we have to talk about crowds in terms of like crowds as a whole, whether you need a diverse crowd, a crowd that has different skills, different knowledge bits and pieces, or whether you need a homogeneous crowd, whether you want to engage with a small or a large crowd. Let's look into two examples, Susanne, please, if you click. On the Suniverse platform, it's really millions of people all around the world who help scientists in the medical sciences, in the life sciences, in astronomy, in history, in art history, in all kinds of fields to basically classify images or video data, large scales of images or video data, to process data in these fields and just to speed up the process. And going back to Ivan's question on data quality, of course, platforms like Suniverse have mechanisms in place where one image is classified by many people. So to level out, to leverage the wisdom of the crowd, to leverage out mistakes in those cases that have differences in classifications are put on a discussion board. So the tricky cases are then discussed by specialists to make sure that the classification is correct. That's, for example, one mechanism to ensure data quality. Another crowd is Epidemium. That's very different from the Suniverse crowd. Epidemium is a crowd, a mid-sized crowd science project in data-based cancer research. And in this project, it's maybe a few hundred people, data scientists, cancer researchers, medical doctors, patients who co-develop research questions in particular fields of cancer research, who co-design studies for this particular research question, who co-implement these research projects, and then who co-publish their outcomes. Yeah. So this is a crowd that is much more diverse than the Suniverse crowd. The Suniverse crowd is a crowd of people with basic cognitive skills. The Epidemium crowd particularly involves patients, doctors, data scientists, and cancer researchers to co-create research projects. Let's move to the next slide, Susanne, please. And I tried to make this short because you can read up on it on the book. But what is also important when you think about crowd engagement is not only to think about where in the research projects, where in the research process can crowds help me to define research questions, to get funding, to collect data, to analyze data, to translate research outcomes. It's also important to think about what is it that the crowd does, what is it that the crowd contributes in terms of what are the activities that the crowd performs as compared to what is it that the scientists do, what kind of knowledge does the crowd bring to the table, what kind of resources, and what kind of decisions does the crowd make, either themselves or co-decisions they make together with me as a researcher. Let's look into this in a bit more detail. So this AKRD, activities, knowledge, resources, decisions matrix is a core tool when we design crowd science projects. And when we go to the next slide, we can also use it to analyze crowd science projects. One of the first large-scale crowd science projects ever was Galaxy Zoo, an astronomy project where a group of astronomy researchers basically put millions of pictures of galaxies on Suniverse, the crowd science platform, and asked everyone to help them classify these pictures. So classify whether that is a spiral galaxy or another type of galaxy. So in this particular case, Susanne, if you click on the next slide, the Suniverse crowd only contributed to one stage of the research process, that is processing and analyzing data. Basically, the crowd classified images of galaxies. Difficult cases that the crowd couldn't classify individually was put into the Galaxy Zoo talk, so to collaboratively classify it. Specialized knowledge was only necessary for difficult cases, but basically all they needed was a crowd of people with basic cognitive skills. The crowd needed to have a computer and internet access to perform this. And the only decisions the crowd took was to decide about the objects that they wanted to classify. Yeah? And if you look up the Galaxy Zoo project, the data that was processed by the crowd contributed to high-level scientific publications, but also, of course, to non-scientific outcomes such as fun and enjoyment of the crowd who participated in this project. Another project, Susanne, if we go to the next slide, I mentioned this. This was a climate research project done in Belgium, in the city of Antwerp, where the citizens of Antwerp were engaged in this project. And Susanne, if you click on the next slide, in more than one stage of the research process. So the citizens also contributed their own money to fund that research project. They engaged not only in processing data, but also in collecting data. So they installed air sample devices on their houses, on their balconies, on their apartments, and in different places to collect air pollution data. They reported traffic data. They needed, of course, common knowledge to do that. But in later stages of the process, they also engaged in co-analyzing the data, better understanding why at a certain point in time the air pollution was so high. And that is something that could have biased the data analysis if the scientists did it themselves. But the citizens knew that at a particular day when the air quality was so bad, they knew there was a big fire in the city, and that fire created the bias in the data. The scientists would have not been able to identify that. And the citizens also contributed heavily to diffusing and translating the results of that research process, also informing policymakers to change environmental policies in Belgium, respectively in the city of Antwerp. So you can see here, this is a project where the crowd was engaged in many more stages of the research process, and the crowd needed to have different kinds of knowledge, contributed different resources, including financial resources, and made more high-level decisions together with the scientists. Let's move on to the next slide, because I'm running out of time. I want to do that a bit more quick. As Susanne already introduced this, a big question in 2025 is, of course, will AI, artificial intelligence, make crowds obsolete? So far, our answer would be no. It's just that the roles of crowds and AI change. And we discussed this in the book as well. Of course, certain tasks that were previously performed by crowds might now be automated. While previously crowds have trained algorithms, for example, for cancer detection, now it is that crowds validate the outcomes of algorithmic cancer detection. But the most important areas are augmentation. So that means that crowds and AI work together in order to improve the quality of their outcomes. And that's another answer to your question, Ivan. For example, when it comes to classification or data collection, crowd engagement activities, you need to have a lot of knowledge to understand whether a certain bird is a certain bird in a sense. You may not know all the species, but AI can help humans to identify species. Another important aspect of how AI can help crowds is by algorithmic management. So AI can help allocate tasks to crowd members. AI can help to individually motivate crowd members to contribute. And AI can also help to improve as a manager then data quality, respectively research integrity on a larger scale. Let's move to the next slide. And yes, Ivan, you raise your hand again. Feel free to speak up.
Yeah, just one thing come to my mind. So what about scalability of data using AI? Does it make sense?
What do you exactly mean by scalability of data using AI? Can you specify?
So if data set is not large enough. So do you know any successful experiments where scalability helped? So using AI maybe recognize some patterns and increase the data set?
I mean, the thing is, there are certain scientific research areas and scientific research questions that require large-scale data to be answered. And previously, of course, for example, let me give you an example. Maybe that helps answering this. There's a group of researchers at Cornell University who study, who are neuroscientists and who study stalling in brains, which is a major driver of strokes. And the kind of data they need is they need to understand when and how and where stalls occur in brains. So what they did is they collected data on they collected data on mice. So mice brain scans. They had lots of videos of mice brains, and the problem was that they had a lot of data, but they were not able to analyze all that data. It would have taken them more than 10 years to analyze all that data. So what they did is, they turned to a crowd. They asked the crowd to help them identify the stalls in these brain scans. And for a task that they required more than 10 years to perform, the crowd was able to perform it in less than 2 months. So in this particular case, a crowdsourcing approach was able to increase the size and the quality of the data in order to train an algorithm that is then used to identify stalls in brain scans. So in this particular case, a crowd and AI worked together to create a large-scale data set that was capable of answering a research question that would have not been able to be answered without the help, this combination of crowd and AI. Is that the question you had, Ivan, or did I totally miss what you wanted to ask?
Yeah, it's close. I just wanted to know the AI impact in increasing data set.
And of course, but this is all, I mean, we have the kind of AI that is accessible to everyone is around for a couple of years. So there are all kinds of studies out there showing us that AI can generate more and better data, but, and Susanne knows a lot more about this, only under certain conditions. And this is why what I said initially, there is AI-generated outcomes need to be validated. And sometimes it can be validated by the scientists, and sometimes it requires crowds because the data is just so much. So an individual group of researchers is not capable of doing that validation. So it's not so much automation, it's more human AI collaboration, also in scaling research data. That would be my answer to your question.
Okay, thanks.
Yep. I see another hand up by Mikhailo. Please feel free to speak up.
Hello. You mentioned several times that ensuring data quality is very important, and my question is about how to avoid intentional vandalism in such project, because there are always people who want to make a mess just because they can. Are there some specific methods or strategies to avoid that?
Yes, absolutely. An important question, Mikhailo. I think this is crucial when you think about setting up or designing a crowd science project. You have to think about very strategically, first of all, why is it that you turn to a crowd? What can the crowd do that you cannot as a scientific research group? And then you need to think about to which extent do you need to enable the crowd to be able to develop quality and avoid sabotage? And I know that, I mean, particularly when it comes to topics that are very controversial, research fields in whatever, climate research and other topics, you have to deal, there's always people around, who use this as a way to drive their own agendas. But that is something you need to take into account by the design of your project, whether it's a unilateral or a bilateral way of engaging with the crowd. What kind of decision rights, and Susanne, if you could go back to the AKRD matrix, what kind of decision rights does the crowd have versus maybe the basic one, like a few slides back, Susanne? Yes, this one. So this is a central tool that we use. What kind of decisions is it that the crowd takes versus the scientists take? Which decisions are taken together by the crowds and the scientists in order to make sure that research integrity, that we live up to the standards of research integrity in the project? So there's hundreds of decisions you have to take in such a project design in order to make sure that what Michaela, what you've been describing does not happen. It would basically be too much to discuss this. We only have half an hour left and I'm already running late. But also, Michaela, if you want to discuss this, feel free to follow up in an email and I'm happy to have a follow-up discussion with you if you're planning a project. Yes? Is that okay?
Okay, thank you very much. It was very informative.
Yeah. And let's take one more question from Alina. Alina, you had your hand raised.
Yes, thank you very much, Marion. I'm so sorry. No, thanks for Russian. I have no electricity right now, so you can see, you can hear. I hope you can at least hear me well.
I can hear you and see you. All good.
Perfect. Thank you very much. I have one question related probably for Ivan's last, because now we are driving a project including artificial intelligence integration for interpretation of amplitude integrated electroencephalography. And this project is related for newborns and children of the first year of life. And this cohort is extremely delicate and extremely complex for all the actors, for scientists, for clinicians. And from your point of view, what the most challenge do you see in this situation for us, especially when we aim to scale this project in the future? Thank you very much.
Oh, that's a difficult question, Alice. I'm currently also involved in 2 projects myself where newborn screening is a part of it. And of course, you have a lot of standards that you need to respect in terms of ethical issues, data protection issues. It's not easy to answer that question. But of course, I think there are federated approaches, that federated learning approaches that enable the collaboration across institutions without the data leaving the institution. And I'm pretty sure you're aware of that. You're probably much more an expert than I am in this. And these federated approaches help very much in scaling this. However, what I have learned is that involving the patients, and in this case, the parents, when it's newborn screening, early on in the design of the project, as co-researchers or co-investigators with respect to ethical issues, with respect to issues related to how to govern these kinds of processes, with respect to information flows, when do you raise red flags and so on. So some kind of co-creation with the patients, or in your case, with the parents, on the one hand side, but also with the clinicians who then use these tools, is very crucial in the setup of this project and will also influence the scalability and the applicability of these projects.
Wow, this was a brilliant answer for me. Thank you very much. This is the point that we will definitely discuss during the next day.
Feel free to reach out in a follow-up email. Yes. So I see Michaela has a hand up, but we have some discussion planned for later on. If you allow me to move through a few slides before we close up, and then we can go into a general discussion. So let's go to the next slide. And one thing that I want to really make you aware of, when you think about engaging crowds, and whether that is for collecting data, for analyzing data, for generating research questions, you have to really think about why would you benefit from crowd engagement, whoever your crowd is, And that is a very important decision to take in the beginning. And for this, together with Susanne and Henry, we have developed the 5 crowd science paradigms that help you make that decision. Let's quickly go through them, starting out with crowd volume. So there are challenges out there as researchers, as you have been describing it, for example, by I think it was Ivan or Mikhailo, how to scale data in a sense. Sometimes you are just faced that you need a lot of data, or And a lot of data collection means a lot of work, and a small research group would never be able to do that. Yeah. So you may reach out to a crowd because you simply need to get a lot of work done. Yeah. So that is a volume argument. Like the Galaxy Zoo researchers, the astronomers, they had millions or maybe billions of pictures of galaxies. They would have never been able to analyze all of them. And yes, today they may reach out and use an AI for classification. But back then we didn't have the kind of AI that helped with this classification. So they turned to a crowd to do that. So that could be one reason to reach out to a crowd, because you need to get a large amount of work done. Another, Susanne, if you move to the next slide, that is a little bit like the example that Susanne gave you with NASA and with the radio frequency engineer who solved a very tricky NASA problem. You may not need lots of people to do lots of work. What you need is one outlier solution that solves a particular kind of problem. We call this the broadcast search paradigm. Foldit is a crowd science platform for protein folding, where hundreds and thousands of people fold proteins, but we don't care about most of these protein structures. We care about this one outlier protein structure that can help us cure Alzheimer's disease, for example. Yeah? And by the way, David Baker, one of the founders of Foldit, got the Nobel Prize in Biochemistry in 2024. So this is high quality work, again, speaking about data quality. Another reason, Susanne, next one, is why you may turn to the crowd is because you need a particular kind of crowd. As scientists, you know about, you have the expertise on a certain topic, but you may not know about the actual problems. Yeah? So you may turn to the people who have experiential knowledge. In medical research, that is, for example, the patients, the nurses, the medical doctors, who have knowledge that you as a researcher do not have, and that can help you to ask better research questions or to analyze data in a particular way that you would not be able to do without the help of patients. Another reason why you may turn to the crowd is because you simply need recombination of knowledge. You know that you need people with different backgrounds to solve a particular tricky problem, such as, for example, in Epidemium, which is about data-driven cancer research, where a crowd of very different people, patients, doctors, medical scientists, cancer researchers, image experts, co-develop novel research projects and answer novel research questions in cancer research. And that is also a question that goes to a thing that goes to the question of Ivan again, and that is what we call crowd wisdom. We know that, and there's quite a lot of research out on this, showing that individual classifications or observations or assessments may be wrong. But if you aggregate independent knowledge and preference inputs, then on an aggregate level, they get it right. Yeah? And this is why Sudiverse, for example, lets 20, 30, 40 people classify each galaxy or each whatever brain scan to make sure that on an aggregate level, the classification is the correct one. And that's the crowd wisdom argument. And overall, Susanne, if we go to the next slide, if you design a crowd science project, and that goes to many of your questions, you need to think about, why do I turn to the crowd? How can they help me solve the particular challenge that I have in my research project? And you may end up combining different crowd paradigms. You may say, well, I need one outlier solution, but I also know that such a solution will likely come from people with experiential knowledge. So I combine a broadcast search paradigm with a user crowd paradigm. And if this is the case, you need to set up your crowd science project in such a way that both paradigms can actually play out in the way that helps you solve your particular problem. Yeah. All right. So that was, usually it takes me hours to talk about this, a very short introduction to crowd science. I see there are several comments in the chat. Susanne, should we address them, or should I round off with industry as a source for scientific research?
I think it would be, if you have 2-3 more minutes on the industry collaboration partners, I think then we can round it off with the open discussion.
Excellent. So Susanne also asked me to talk a little bit about industry as a source of innovation, and now, of course, as a source of innovation for science. Yeah. And I particularly would like to draw your attention to new ways of open industry-university collaboration models, because I believe that they are particularly interesting also for you as scientists in Ukraine, because these platforms openly share all their data, materials, code to be taken for commercialization. And what do I mean with open university industry collaboration models? Here you see 5 examples that share common characteristics. Odin and Plant to Food are 2 open innovation science platforms in Denmark, sponsored or funded by the Novo Nordisk Foundation. Odin for drug discovery and Plant to Food for plant and food science. Then we have the Structural Genomics Consortium that many of you are familiar with. Open Targets is also a drug discovery a platform, or the Early Drug Discovery Unit at Edouard McGill University in Canada. And while you all may be familiar with traditional university industry collaboration based on intellectual property rights, based on contract research and in or out licensing deals, Susanne, if we go to the next slide, these new forms of open university industry collaboration, they share a couple of common characteristics. So most of the time, they operate in the pre-competitive space. So they are pre-competitive public-private partnerships operating in TRL levels 1 to 3, so very early stage research. These platforms also facilitate inter- and transdisciplinary exchange of knowledge and resources between academia and industry. These platforms usually do basic research. Some of them, like Odin or Plant to Food, do use-inspired basic research. And I think that could be really interesting for you to think about if we turn to Pasteur's quadrant on the right-hand side of the slide. Pasteur's quadrant helps us classify different types of science, according to whether there is a quest for fundamental understanding on the vertical axis and whether there are considerations of use on the horizontal axis. And we talk about pure basic research if there is a quest for fundamental understanding but no consideration of use. Usually we show Niels Bohr, or the usual charts show Niels Bohr in this quadrant, but we need to raise female scientists here, so I put in Marie Curie as an example of pure basic research. If there is no consideration of use, if there is a consideration of use but no quest for fundamental understanding, we usually talk about pure applied research, such as Thomas Edison. Thomas Edison was not interested in the workings of light. He wanted to develop the light bulb. And then there is the sweet spot here that is called use-inspired basic research. And many of these open platforms try to bridge the best of both worlds in a sense. And what you can see here is Louis Pasteur, a picture of Louis Pasteur, because Louis Pasteur was not only interested in the basic understanding of how bacteria work, he also was inspired by the problem of why does milk get sour? So in the end, his quest for basic understanding of the workings of bacteria also then resulted into real-world problem solving with high impact with pasteurization processes that extend the shelf life of food products. What is also interesting about these open university industry collaboration models is that they usually forego all intellectual property rights. There was a question about IP before. So people engaged in universities and industry partners engaged in these open university industry collaboration models, they contractually agree that all the intellectual property that they produce, research results, data, code, materials, are openly shared with anyone. Why? In order to basically kill 2 birds with a stone. These models are supposed, by combining diverse knowledge across academia and industry, generate more high-risk, high-gain research in the fight against the increasing incrementalism in science that Susanne brought up in the beginning, and at the same time, accelerate the pathway from scientific discovery to corporate innovation. And before we close up, I brought one example that we can dive into a little bit deeper. The Odin platform is an open innovation science platform in Denmark, funded by the Novo Nordisk Foundation and run by Aarhus University. And in the Odin model, we have scientists and industry partners who engage in open collaborations where Scientists and industry partners inspired by real-world problems out there generate use-inspired basic research project ideas, turn these ideas into research proposals. The best proposals get funding, and once they got the funding and engage in the research, they commit to openly share all their data and foregoing all intellectual property rights. Later on, when these projects are finished and all their outcomes are shared, then of course, either the project partners in joint innovation project can translate them into more applied projects with intellectual property right protection, or the companies engage in in-house R&D with intellectual property right protection, or spin-outs from academia or industry turn the outcomes of these research projects into deep tech startups for new drugs and diagnostics. And final slide, Susanne. And the way this works is that the Aarhus University Open Innovation Science Center at Aarhus University facilitates co-creation sessions among academia and industry in order to identify novel problems, co-create novel research proposals, co-write grant applications. The best applications get funding from the Novo Nordisk Foundation, and later on, the inter-transdisciplinary research teams then co-execute these research projects and openly share all their outcomes with the general public. And again, what is the rationale of doing so? In order to, on the one hand side, of course, enable the uptake of these results by the involved partners, but also enable other actors, other scientists, other companies, startups to engage with the outcomes and to translate the outcomes into actual innovation, in this case, in drug discovery. So this is my 2 cents. Susanne, hand over to you, and then we go into a general discussion.
Wonderful. Thank you so much, Marion. And I already saw the very super interesting questions in the chat that we can discuss in a moment. By closing, I just want to share a little bit, to take everything that we say with a little bit grain of salt, as you would say, because all these collaborations and different forms of collaborations can be very powerful and inspiring, and it can be helpful in order to achieve a larger goal. But again, they're not an end in itself. It's not about always being open or always collaborating. It's definitely not an end in itself. The second grain of salt that I want to share is that there's no linear positive relationship between openness and performance. So we have emphasized that the diversity of actors that are engaged in a collaboration can enrich a project, but by no means we want to say that, the more people you have engaged, the better the output will be. There's no linear positive relationship. There's always the question of when does it make sense and whom should we engage with. And I think the crowd paradigms that Marion shared is a nice example. We need to be very clear on why we want to engage with crowds or why we want to engage with industry partner. And to answer that question, we need to keep in mind all these different boundary conditions or contingencies that we have talked about. So this is just the grain of salt. So we don't want to be, we advocates for openness, yes, but with a big but, and that it all needs to be within a reasonable frame and purpose. And there is a bit more summary in the slides that I'm going to share, what's kind of wrapping up the entire idea of open innovation and science research. But I think you all have it fresh in mind, and I don't want to spend time on this, but instead really move on to the open discussion and to share the last 10 minutes or so with you in an open discussion. So I'm stop sharing so that we can see each other and opening the floor to questions. And Victoria, you now had you were the fastest in raising your hand. Please speak up.
Yes. Hello. Thank you very much. Yes, I was very quick because my battery almost died, so I will be super quick. And first of all, I really very thankful for you, because it's obviously you have extensive experience in organizing crowd-involved, international and interdisciplinary projects. And I am super impressed, and I took maybe 1 or 2 things to consider for future my researchers. So my question probably will address to you, Susan. So you have already admitted the possible challenges that can occur within this collaboration, but which skills do you think are the most important for successful leading and coordinating maybe these interdisciplinary teams?
Wow, this is a hard question to answer. Marion, be prepared that I'm gonna give you the word on this one.
Maybe
But
some big top skills, okay?
I think there's no, if there would be a silver bullet and one solution fits all, then I think we wouldn't need so much research on this. But I think one skill, so there's this idea of absorptive capacity. So this is one thing that immediately comes to my mind, which is kind of the capacity to identify, absorb, and integrate the knowledge that you see where else into your own thinking. So it comes from organization and innovation research, but it's also something you can apply to the individual level. So trying to be open and trying to be aware of the own frames, cognitive frames that we have is extremely hard, but also extremely important, I would say, for running interdisciplinary and large collaborations.
Okay, I think that yes, this is right. Okay, thank you very much again for this informative presentation. You're brilliant. Thank you very much.
Thank you. But please, anytime, please reach out if you want to discuss that further to whoever. We really love to speak about these things. Marion, do you know who was second? I think
Mikhailo had his hand up already in the talk, so I would give the word to Mikhailo and then maybe to Maikova and then to Olga.
Okay. One of questions raised another questions. There was mentions of problems with working with medical data, ethical and problems and juridical problems. And my question is homomorphic cryptography actually used in such cases in real world projects, or is it currently only on paper? I mean, the kind of novel cryptography which allows calculations on encrypted data without decryption.
Mikhail, I'm not a computer scientist, so this is a question that I can only answer more broadly. Yes, I've been talking to computer scientists in different projects where we try to see which latest technologies can we use in order to kind of speak to different kinds of goals. That is ethical issues, that is data quality issues, and that is also data protection issues. Because whenever we engage in these crowd projects in the medical context, for example, we have particular challenges with respect to GDPR, particularly when we are running projects in the European Union. And we have, for example, unfortunately, we had to kill one project that I've been working with because of GDPR reasons and because we did not find a technical solution that could fulfill all the requirements with respect to GDPR. So it's a difficult challenge. If you have any suggestions, like from novel developments in computer science, I'm happy to learn about them, but I'm not able to answer your specific question because this is not my home turf. Maybe Susanne, you can help here.
I think, I fully agree. I think you covered the basics. I can't add anything to this question.
I'm sorry, Mikhailo.
I just wanted to know, is this technique already used? It seems like it's not yet. Thank you.
Yeah, and I'm sorry to interrupt. We have just 5 minutes. So I would just kind of, Mikhailo, thank you for the questions, but I think we still have 2 hands, so let's try to cover them too. Sorry. Jana?
Good evening. I'm sorry, unfortunately, probably I didn't catch some information because of bad electricity. When you were talking about these platforms like Zooniverse and other about cancer research, they seem to be mainly an excellent system for finding colleges and research among scientists. I'm interested in does business use them at all too?
I'm sorry, Jana, you were falling out during the question. Could you repeat it? I didn't get everything. Could you repeat the question, please?
Yes, of course. I didn't catch some information because of bad electricity, unfortunately. When you were talking about these platforms, the universe and other about cancer research, they seem to be mainly an excellent system for finding colleges and research among scientists. I am interested in does business use them as well?
Okay, thank you. Now I get the question. So first of all, Jana, I mean, today we were talking about how to use this platform for scientific research. So scientists as the users of these platforms. But crowdsourcing or crowd platforms have been around for companies much earlier, and companies heavily use these platforms, but then not Zooniverse, because Zooniverse is particularly a crowd science platform, but platforms such as Kaggle.com, Susanne, maybe we can type them into the chat, Kaggle.com, Innocentive.com, Topcoder.com, leadingedgeonly.com are platforms that are mainly designed for corporate use, where companies post challenges to be solved. And some of these platforms have a very general crowd, but Leading Edge Only, for example, is a crowdsourcing platform that particularly helps companies to connect to scientists, where the scientists is the crowd and the companies are the solvers. So yes, companies very extensively use these platforms for problem solving, but it depends a bit on what challenge they face. If they have a data science challenge, they may go to Kaggle. If they have a challenge with respect to corporate R&D, they may go to Leading Edge Only or to Innocentive.com. If they want to have a creative problem-solving process, they may go to IDEO or to 99 Design or something like this. So there is a platform for everything, yeah? And you need to match whatever challenge you have with the platform and the respective crowd that you reach out to. But these paradigms that we introduced, you can use the logic or the rationale of these paradigms also in a corporate context.
Thank you.
So then we have Olga.
Yes, thank you very much for your presentation. It was very insightful and brought many interesting ideas for me. And I just wanted to share my personal experience. We had some collaboration with sharing experts in metallurgy, welding, material science, and legal field for some reason. And it was a good match between the five of us. But at some point, our collaboration started just disintegrating for some reason. And I had a question if you have any insights into managing these projects in the long term.
Oh, yes. Oh, yes. Yeah. But so seriously, I would love to share this in a one-on-one afterwards, because managing different scientists is honestly, it's like herding cats. It's exactly the metaphor that I'm using when we speak about our 50 plus people collaborative efforts, where we also have like all these different minds and they all work differently and they all have different priorities. And they want to have things included in the paper, and others say no, that doesn't matter. And then you try to find out why they have these differences. And we had three large collaborative papers with each over 50 people or almost 50 people. And every single project was designed very differently because the purpose was a different one. One was more about integrating the knowledge. The other one was more in collecting the experience. And the third one was really going in depth, where we really wanted to clarify a specific conceptual aspect. And each of these purposes required a different process. Like where we go in depth, we split up into small subgroups. Where we wanted to collect the data, that was the easiest one, because then you design the challenge and they go and they work, and then they give you the knowledge. It's more about managing them. And probably the hardest one was the first one, where we wanted to integrate all the knowledge. But I'm happy to share my experiences with that. Yeah, it's super rewarding, but challenging as hell.
Thanks.
Maybe one comment on this. Olga, we have in the book, in the open access book, we have an entire chapter on organizational challenges and remedies. It's chapter 15. And yes, it's mainly with respect to crowds, but our understanding of crowds is very wide. So it's crowds of scientists, crowds of users. So maybe something helpful can be found also in chapter 15 of the book.
Thank you, Marion. Thank you, Susanne, for your time, for your expertise, for being so honest and sharing kind of your thoughts and ideas. And I think we had lots of questions in the chat and also comments that it's something new for the researchers and scientists, young scientists in Ukraine. So thank you for your time and to kind of sharing the knowledge. Sharing is caring. So thank you a lot. And I'll be asking also to share your presentation afterwards with me so I can distribute them with the group. Thank you for your time one more time, and have a great evening all.
Thank you so much. Thank you so much for the invitation. It was great talking to you. And as we said, like if you have any follow-up questions, if you have any projects in mind that you wanted to discuss, please reach out. We're very happy to discuss them with you.
And Juliana, you're welcome to share our email addresses with the group so that they can reach out to us if anything comes up. Yep.
Perfect.
It's great meeting you. Thank you very much. Have a lovely evening.
Bye.
Thank you very much.
Thank you so much.
Thank you
Bye
very
bye.
much.
Thank
Thanks a
you.
lot.
So